Hello everyone, and welcome to 11.1 Part 2, which is all about factorials. And I know some of you have had experience with a factorial before, so I'd like to remind you about all of its awesome qualities. So a factorial is a positive integer, and it is defined as the following. Now, yes, it says an exclamation mark, so you could absolutely think of it as a really exciting number. I mean, I definitely do, because factorials are just, honestly, one of the best things ever, but it is not really like n, go n. It's more of a definition of a lovely pattern that we notice. N factorial means that you take the number itself that you're on, then you multiply it by every number below until you end with 1. So for instance, if I wanted to find 5 factorial, that would be the number itself times the consecutive number below it, times the consecutive number below it, times 2, times 1. So in this case, if I actually multiplied all of these together, that would be 120 as my answer. So 5 factorial would be the number 120. So what you're really doing is multiplying the number itself times every number below it. So we'll be doing more examples in a minute, but something I want to point out to you is let me first write 3 factorial, which is really the number itself, times 2 times 1. So the answer we know is going to be 6. Now, even though this is not technically part of the sequences in series unit, I wanted to tell you that a factorial is really also part of the permutations and combinations unit. The reason I bring it up is going to help us understand this special case in a minute. Now, a permutation is writing numbers in any particular order. You can switch the order. So I decided to write this because the definition of a factorial is 3 times 2 times 1. But couldn't I take these numbers and write them all in a different way? Couldn't this be 3 times 1 times 2? That would still get me 6. I could do 2 times 1 times 3, or 2 times 3 times 1. Or I could do 1 times 2 times 3, or 1 times 3 times 2. So the reason that the answer of 3 factorial is 6 is because there are 1, 2, 3, 4, 5, 6 different ways that you can organize the numbers and multiply them to get you that final answer. The reason I bring that up is because there's a special case for factorials, and that is 0 factorial. What I want you to think about is that when you have a factorial, you're multiplying every number below it until you end at 1. Well, 0 is already below 1, so how many ways can I organize 0? Like 3 factorial, I could organize it 6 different ways. How many ways can I organize 0 factorial? Well, only one way. So that is why 0 factorial equals 1. It also kind of reminds me of the special case in exponent rules as well, when you had any number like 3 to the 0th equals 1. It's somewhat of an expectation in mathematics, that's just understood. But I wanted to at least explain to you why this is true. And I hope you know why this is true from back in the algebra days. But I think those are both just things that you have to know. With some of these evaluating examples. Before we start, I'm going to write a note that something I generally try to do is try to break down the larger factorial first. It's generally what you're going to notice me doing. So if I think about that and look at this first example, what we want to do is try to simplify this as much as possible. The largest factorial that I see is 6 factorial. So what I'm going to do is start using the definition. What this really means is 6 times 5 times 4 times 3 times 2 times 1. But instead of writing 3 times 2 times 1, I can end this with just 3 factorial. Why would I do that, do you ask? Well, I happen to notice that on the top of my fraction, I already have a 3 factorial. And so if I have 2 of the same thing, I can cross them out. So what this becomes is 2 factorial over 6 times 5 times 4, which is really 2 times 1 over 6 times 5 times 4. And you can keep simplifying this any way you'd like. If you notice that the 2 and the 4 can reduce, you can do that. If you notice that the 2 and the 6 can reduce, you can also do that. You could also just multiply top and bottom and get 2 over 120, which would reduce to 1 over 60. So this would be your answer for the first example. This example here, I want you to think about which one of these is actually larger. And think about, again, the definition of a factorial, that you start at the number that you're on and then keep going downwards. So if I started with n factorial, the next one in line would be n minus 1. If I started with n minus 1, the next one in line would be n minus 2. So it seems to me that this is the larger factorial. And so if I start writing the definition again, this would be n times n minus 1, and then I could keep going forever, n minus 2, n minus 3, n minus 4, n minus 5. But again, I notice that I have an n minus 1 factorial on the bottom. So instead of writing n minus 2, n minus 3, n minus 4, all of that is implied in this symbolism. And so these are the same top and bottom, so I can cross them out. So my final answer is just n. This next example, if you could please pause your video, I would like you to try this one on your own. Remember, break down the larger factorial first. I will come back with the work. So please pause now. All right, guys, so here's what I did on this example. I noticed 6 factorial was larger, like this example here. I wrote it as 6 times 5 times 4 times 3. Notice that there was a 3 factorial on the top as well, so I stopped here, crossed this out. If there's nothing left on the top, I put 1 as a placeholder. 1 over 120 was my final answer. This example as well, I would like you to pause your video again and try this one with that same logic, and please start with the larger factorial. So please pause now. All right, so my final answer on this example was 4080 because I wrote this top factorial by definition is 17 times 16 times 15 times 14, 13, blah, blah, blah. But again, I noticed that there was a 14 factorial on the bottom, so I stopped at 14 factorial, crossed out the like terms, I guess you could say. Then you're left with 17 times 16 times 15, which got me that final answer. All right, these two examples, again, the symbolism sometimes can be strange, so let's think about on this one which one's larger. Well, if I start with n minus 2, the term after that would be n minus 3, n minus 4. And if I started with n factorial, that would be n minus 1, n minus 2. So it seems like this one to me is larger. So I'm going to start with the bottom, write it as 2n times the next term, n minus 1 times the next term, n minus 2. But I notice that there is an n minus 2 factorial, so everything below n minus 2, and this could be considered everything below n minus 2, so they can both cross out. So I'd be left with 1 as a placeholder on the top, 2n times n minus 1 on the bottom. Now, you could keep your answer like this, but just for the sake of simplification, and I would ask your teacher about this, you could write your final answer as 2n squared if you distribute in minus 2n. This is probably the way I would like the final answer, but please again ask your teacher. This next example, again, which one is the larger factorial? Well, this one starts with n plus 2, so the next one would be n plus 1, and then n. So n would just be n minus 1, n minus 2, and so on. So again, it seems to me that this one is the larger. So I will start with that, and I will start by the definition, n plus 2 times n plus 1 times n. But again, I notice that there's an n factorial on the bottom, so these two continue on forever down. I'm going to cross those out because it's going to be the same terms over and over. So I'm left with n plus 2 times n plus 1 in the numerator. And again, let's just go ahead and simplify that. So if we FOIL, we get n squared plus 1n plus 2n plus 2. So your final answer would be n squared plus 3n plus 2. All right, last example. Find the first 4 terms. And so this is another one that I would like you to try on your own first. What your goal is, kind of relating to the last video, is to find the first 4 terms. So you want to find a sub 1, a sub 2, a sub 3, and a sub 4. And remember, the 1, 2, 3, and 4 represent the position that you're on, and the values you get out will be your output terms. So please pause the video now, plug them in, and let's see if we get the same answers. All right, let's see if anyone got the same answers as me. A sub 1, my output was 1. A sub 2, my answer was also 1. A sub 3, my answer was 1/2. And A sub 4, my answer was 1/6. So let me explain really quickly how I do these, because it might save you time. When I use the factorial, this first one was not too bad, because 1 factorial is really just 1. But on the second example, when I wrote 2 factorial, instead of multiplying everything out, I noticed that the 2's could cross out top and bottom, so I was really left with 1 over 1, which is how I got my answer quickly. A sub 3, I wrote as 3 over the definition, 3 times 2 times 1. Again, to make my life easier, I crossed out the 3's and was left with 1 over 2 times 1, or 1/2. And last but not least, 4 over 4 factorial is 4 times 3 times 2 times 1. Crossed out the 4's, was left with 3 times 2 times 1, which is where I got the answer of 1/6. All right, guys, so we'll be practicing these 2 sections in class tomorrow. Thank you so much for paying attention, and I look forward to seeing you in the next video. Thank you.